Throughout history, inventions that have changed life, such as the electric bulb and the internet, have reshaped our world. However, beyond these famous advances, there are forgotten technologies, brilliant ideas that have never seen the light of day. Hindered by corporate interests, shrouded in government secrecy, or overlooked by skeptical scientists, these innovations have been kept in the shadows without ever reaching their true potential. Join us to discover 10 forgotten inventions that could have radically changed our world. Number 10. The Ogle Carburetor. Tom Ogle, a self-taught mechanic from El Paso, Texas, came to public attention in the 1970s thanks to an invention that seemed incredible. The Ogle Carburetor was his invention, which he claimed significantly improved fuel consumption at a time when the world was going through an oil crisis. Ogle invented a device for cars designed to allow travel over a distance of more than 74.565 miles with a gallon of fuel, which sparked great public interest and optimism about fuel economy. Unlike traditional engines, which used carburetors to mix air and fuel for combustion, Ogle's invention eliminated both the carburetor and the fuel pump. In their place, he introduced a black box that sprayed the fuel and burned the gasoline before it reached the engine. As a result, very little fuel was needed to get the engine running. This revolutionary approach promised not only savings for consumers, but also a reduction in oil dependency and vehicle emissions. In 1977, Ogle presented a modified 1970 Ford Galaxy, which demonstrated remarkable fuel efficiency, causing a real media frenzy. The invention attracted the attention of investors and major corporations interested in its potential to transform fuel consumption. However, the auto industry remained skeptical, questioning how Ogle's carburetor could achieve such efficiency without major engine modifications. Undaunted, Ogle defended his invention, refusing large offers for his patents, hoping for widespread use of his technology. Tragically, Ogle's life was cut short in 1981 at the age of 24 under suspicious circumstances. His death was officially classified as an overdose of alcohol and prescription drugs, but many of his friends suspected that there was foul play involved. At the time of his death, considering the huge financial stake tied to his invention, it led to some conspiracy theories. Some suspected the oil industry, which saw his invention as a threat, while others speculated that car manufacturers might have been involved, fearing the potential disruption to their business. After Ogle passed away, his invention was forgotten. The hemp-bodied car during the Industrial Revolution and the Second World War, in the 1940s, Henry Ford, known for introducing the Model T to the market at the beginning of the 20th century, came up with inventions that exceeded the production standards of the time. This genius, already recognized for his innovative thinking, was ready to take things to the next level. It wasn't just about environmental sustainability, a concept that has drawn global attention more recently. His vision was to create a car not only fueled by biomass fuel, but also made from it, with hemp as the main material. This eco-friendly vehicle, later named Ford 420, sparked curiosity and raised questions. How could authorities restrict or condemn a car made entirely of hemp? Ford's commitment to renewable resources was not a passing concern. He had long advocated for the integration of agriculture with industry, convinced that farms could be essential sources of raw materials for production. The concept of the hemp car was a direct result of this belief, highlighting Ford's dedication to exploring alternative materials and energy resources. Built from a composite material that contained hemp fibers mixed with other plant-based elements, the car's body was lightweight, durable, and biodegradable, a rare combination in auto design. This innovative material had a tensile strength reported to be 10 times greater than that of steel, enhancing both safety and environmental sustainability. Furthermore, Ford designed the car to run on hemp biofuel derived from hemp seeds. This choice aligned with his visionary plan to reduce dependence on non-renewable energy sources. Hemp biofuel was considered a viable and eco-friendly alternative to gasoline, producing less pollution and steering America towards energy independence. When the hemp car was launched on the market in 1941, everyone was waiting for its mass production. One of the most memorable and effective advertisements involved the actual destruction of the car. Ford used a hammer to hit the hemp-made vehicle, clearly demonstrating that the material was extremely durable. However, despite the enthusiasm and potential, Ford's hemp car did not advance beyond its initial debut. Many challenges arose, hindering the further development of the project. At that time, the oil industry was in full expansion and was consolidating as an essential element of the global economy, which made the acceptance of alternative fuels and materials difficult. The significant economic and political influence of the oil industry has hindered projects like Ford's hemp car, while the strategic importance of oil made it a major priority. In addition to these obstacles, hemp cultivation faced increasingly severe restrictions due to its association with psychoactive varieties, which intensified legal resistance and culture against Ford's project. As World War II escalated, industrial priorities massively shifted towards war productions, pushing the hemp car into a secondary plan. Ultimately, Ford's ambitious project, with its potential to revolutionize the auto industry through sustainable practices, was largely forgotten, a sacrifice of powerful industries, societal priority shifts, and a cultural environment unprepared for such a radical innovation. 8. The structural effect of Viktor Grabenikov's cavities might seem like a character from a science fiction novel, but his story is firmly anchored in the fascinating world of entomology and an unusual phenomenon he called the structural effect of cavities. Grabenikov, a self-taught Russian entomologist, dedicated years to studying insects, convinced that they hide secrets of extraordinary abilities, such as anti-gravity. In the 1980s, Grabenikov's life took an unexpected turn during an exploration of the vast Siberian steppes. While resting, he had a headache, tinnitus, and a strange metallic taste in his mouth. Beneath him was not just the Siberian soil, but a real underground city of a beehive. This unusual encounter caught his fascination for the architectural brilliance of beehives and their unique structural properties. Driven by an unrelenting curiosity, Grabenikov began experimenting with parts of the beehive. He noticed an unusual warmth emanating from the honeycomb structures, a sensation that defied conventional scientific instruments. Fascinated, he developed a hypothesis that the geometric patterns of the honeycomb generated a force field capable of altering the environment in mysterious ways. Grabenikov's investigations intensified when he turned his attention to the chitin shells of insects. Under the microscope, he discovered a rhythmic, highly ordered structure that seemed to demonstrate anti-gravitational properties. In a remarkable experiment, he aligned two chitin plates, causing one of them to briefly levitate in the air before settling down again. This observation stimulated the next phase of his research focused on harnessing the anti-gravitational potential of these natural structures. Convinced that his discoveries have revolutionary implications, Grabenikov built a platform equipped with thousands of insect chitin shells on the underside. According to his statements, this platform functioned as an anti-gravitational device, reaching speeds of up to 931 miles per hour and rising up to 328 yards. Moreover, he claimed that it made the user invisible from the ground and created a force field that neutralized inertia and dynamic pressure. Given the astonishing nature of his claims, Grabenikov faced intense skepticism from the scientific community, who considered his work impossible to achieve. In 1992, Grabenikov tried to patent his invention, but without success. Undeterred, he documented his findings in a book, complete with color images, which likely showed photographs from a museum demonstration of his invention. However, the book was mysteriously altered even before publication. Hundreds of images and sketches essential for understanding his work were removed. This inexplicable censorship raised numerous questions about the motives behind the alteration of his publication. Number 7. The water-based fuel cell. Here's another story that explores the complex reality of banned technologies and the suppression of their inventors. Stanley Meyer, an innovator from Ohio, significantly reshaped discussions about alternative energy in the 1980s with his revolutionary invention known as the water-based fuel cell. This device was not an ordinary electrolysis apparatus. Meyer boldly claimed that his invention could break down water molecules into hydrogen and oxygen using a minimal input of electrical energy and resonant frequencies, a technique unheard of at that time. Meyer demonstrated his revolutionary technology in a dune buggy, which he claimed could run exclusively on water, using the gases generated by his cell for combustion. Imagine a car moving down the highway, its tank filled only with purified water derived from rain, seas, or even melted snow. In addition to inspiring the creativity of ordinary people, his invention had the potential to provide the world with an inexhaustible source of clean and renewable energy, capable of replacing petroleum-based fuels which deplete natural resources. This generated a huge wave of enthusiasm around Meyer's invention, known as the water-based fuel cell. He was presented by local news producers as a man who was making one of humanity's enduring fantasies a reality, developing vehicles that ran on water. However, while Meyer's discoveries captivated the public, scientists rejected his claims with much suspicion and doubt, questioning the credibility and methods by which Meyer arrived at these conclusions. Unfortunately, Meyer's inspirational story would abruptly and bizarrely end on March 20th, 1998, while he was dining in town. In a tense moment, Meyer rushed out of the restaurant, gasping and clutching his throat, shouting, "He poisoned me!" After a few minutes, he collapsed and died. The cause of death was falsely reported as a cerebral aneurysm. However, this explanation did not prevent the emergence of many conspiracy theories. Meyer's most devoted supporters were convinced that his invention had made him a viable target, as it threatened the monopoly held by the global oil industry. After his premature death, interest in Meyer's water fuel cell continued to grow, with various groups and enthusiasts trying to reproduce his revolutionary technology. Despite their dedicated efforts, they were unable to conclusively demonstrate a working model that reproduced the impressive results that Meyer claimed. This inability to verify his claims only fueled further speculation and mystery around the feasibility of his device, dubbed the radiant energy source. The questions remain: was Meyer's invention truly revolutionary, or was it just a case of science being suppressed by powerful interests? Number 6. Your ASPXJET. The search for the renovating system PETOL, that is vertical takeoff and landing, led to the creation of many experimental designs. One of the most intriguing among these is the Williams X-Jet, developed by Williams International, a company renowned for its expertise in turbofan technology. This evolved into a new and promising vertical takeoff and landing system called the Williams Aerial Platform, or WASP, known as the X-Jet. This small and lightweight vehicle of its aviation design was powered by a turbofan engine designed in a simple but extremely technologically advanced way, which differentiated it from all other vertical takeoff and landing creations of the same period. Designed for a single operator, the X-Jet had an innovative control system in which the user could maneuver the device in the desired direction by tilting and manipulating the power. Thanks to this simple but creative control system, combined with the need for speed and powerful engines, the X-Jet turned out to be maneuverable in any direction, gaining acceleration, leveling, and twisting capacity on each axis. The device could fly for a maximum period of 45 minutes, and had the ability to move at a maximum speed of 49.7 miles per hour. In these, the former Williams jet was pushed to the forefront of Formula One aeronautical technologies. Despite its impressive design and capabilities, the jet faced challenges in the 1980s. The United States Army viewed the former jet as a component in the development of new vertical takeoff and landing technologies. For a long time, the Army was intrigued by such a system due to the improvement of transport and tactical agility compared to conventional helicopters and airplanes. The X-Jet presented an interesting option for individual soldier mobility. However, after a critical analysis, the American Army concluded that although the Williams X-Jet was scientifically advanced, it did not offer the capabilities of the helicopter and the unmanned miniature aerial vehicle. This decision was influenced by the limited range and reduced load capacity of the X-Jet compared to helicopters. The rapid development of drones, which offered flexibility without endangering a pilot's life, eliminated the attractiveness of the X-Jet. Also, practical issues arising from the X-Jet's design, especially the training regime required for pilots to operate this device, introduced additional difficulties for its adaptation to military use. Number 5. The radiant energy device. In the 1930s, in the midst of modern physical development and unprecedented research activity in this field, Henry Murray came up with an idea that could hardly be called anything other than science fiction. However, he introduced the world to his radiant energy device, a new invention on the market which he claimed could exploit forces from space. According to Murray, this device was capable of capturing an unknown and untapped source of energy, which would have revolutionized energy generation as a power source. Murray, an electrical engineer and physicist born in Salt Lake City, Utah, was inspired by the theories of early scientists who experimented with electromagnetism and radioactivity, including Nikola Tesla. In these intellectual explorations, Murray distilled a vision. There is always a type of energy around us, and if it could be exploited as a source of energy, we would never run out of fuel. This device, which was supposed to be used to transform cosmic energy into electricity, had been in development for 20 years. Its main part included a valve, a semiconductor that could take heat from the surrounding environment and transform it into high-voltage electricity. Murray's approach did not claim to violate the laws of thermodynamics. Rather, it was a conversion process, transforming already existing energy from one high form. The demonstrations of his device were spectacular. At exhibitions, he powered bulbs, radios, and engines before an audience. All this without any visible connection to a conventional energy source. However, despite these impressive demonstrations, the scientific community met Murray's claim with deep skepticism. Critics pointed out that the device's operation and basic theory were not sufficiently explained or documented to allow independent verification, or its reproduction. Murray's reluctance to fully reveal his inventions amplified this skepticism. He cited fears about intellectual property theft and potential misuse of his technology as reasons for his secrecy. In addition, Murray's ideas did not align with established physics, which further fueled his colleagues' doubts. As if scientific opposition wasn't enough, Murray spoke of acts of sabotage and persecution. He claimed that his revolutionary work had drawn the attention of powerful entities in the existing energy sector, entities that perceived his invention as a direct threat to their dominance. According to Murray, these forces did everything possible to hinder progress, including threats to his safety, break-ins at his lab, and deliberate destruction of equipment. Despite these challenges, Murray remained determined, constantly perfecting his potential risk and advocating for its potential benefits. However, without the necessary support to advance his work, the invention gradually fell into oblivion, overshadowed by the skepticism and hostility that had pursued it from the beginning. After Murray's death, his radiant energy device fell into obscurity, largely forgotten, except by a few who considered it a strange but fascinating chapter in the history of alternative energy research and energy machine development. Number 4. Paul Panton's jet fuel processor. Paul Panton was an inventor who made bold claims about transforming waste into energy with his revolutionary jet technology, the global environmental energy technology known as the jet fuel processor. Developed in the 1990s, this device promised a significant leap in energy efficiency by transforming a mixture of 80% water and 20% fuel into a clean-burning plasma gas. Panton claimed that his technology could power engines using only a fraction of the usual fuel, dramatically reducing emissions and potentially decreasing our dependence on conventional fossil fuels. The jet fuel processor operated on what Panton called plasma technology. In essence, they used a reaction chamber where vapors from a mixture of water and fuel were transformed into plasma that could then power internal combustion engines. Intrigued, Panton suggested that the system could potentially operate on a variety of fuel sources, including used motor oil, old paint, and even coffee grounds. This presented an interesting prospect for drastically reducing waste, while at the same time offering a more sustainable energy solution. However, Panton's journey was full of challenges. Despite demonstrating his invention at various exhibitions, he faced harsh skepticism from the scientific community. The situation worsened when legal concerns and fraud allegations arose, severely damaging the credibility of his work. Eventually, Panton was institutionalized, and many of his supporters believed this was a ploy to neutralize and marginalize his invention. This drastic move raised many questions about the authenticity of this revolutionary work. Panton's journey, alongside Victor Schauberger's struggle, an Austrian naturalist and inventor, shows a life dedicated to studying water and energy flow in nature. Schauberger, born in 1985, developed theories and inventions based on his nature studies, which many have linked to perpetual motion, a machine that can run indefinitely without external energy input. This led to the creation of inventions that documented the natural patterns of water flow and the energies contained in it, with the intention of efficiently utilizing this information. Both Panton and Schauberger represent the struggles of any innovator who dares to dream of a world where energy sources are significantly different. Their stories illustrate how the best inventions and innovations have never been without controversy and doubt. As we explore new energy solutions, we are left to wonder about the contributions that Panton and Schauberger have made as creative pioneers in trying to decipher sustainable energy solutions for the modern world. However, as we can see, Schauberger never considered himself an inventor of perpetual motion machines. He directed his energy towards the affirmative use of Earth's force, especially the electricity found in the vortexes of the water body. Schauberger's actions stemmed from his belief in understanding nature and its laws. He felt that modern technology and engineering failed to capture and apply these laws in energy generation processes without having negative consequences on the natural environment. The one in the dazed blouse understands nature, then copies nature, encapsulates his philosophy. Schauberger proposed that water, when allowed to flow in a vortex, can generate its own energy through implosion, a concept contrary to explosion-based technologies such as combustion engines, which dominate human innovations. One of his most significant contributions was the research of vortex dynamics. They observed that the water in rivers and streams naturally follows a spiraling trajectory, which they considered essential for maintaining the vitality and energy of the water. By mimicking these natural patterns, Schauberger invented several devices intended to produce energy or propulsion. One of these inventions was the repulsion, a saucer-shaped machine that propelled itself through the waves formed on its surface, generating air or water vortexes. This invention sparked the interest of many people, and some began to claim that Schauberger had discovered the secret of perpetual motion and the source of free energy, although such speculations were considered unfounded. Unfortunately for him, his work was noticed and appreciated by the German government during the World War II. It is said that he was forced to invent for the German army, which was a terrible experience for him, making him cautious with many of his future inventions. After the war, Schauberger continued his work, but his inventions failed to capture either the market or the academic acceptance he desired. Things took a dramatic turn when he was arrested by the American Intelligence Service Agency and detained for 9 months during his activities. For a year, he was held in South African military detention, and all his documents and prototypes were confiscated. He was interrogated about his inventions and experiences during the war. This episode fueled debate about whether Schauberger's advancements in harnessing natural energies were revolutionary enough to be suppressed by the American administration in order to maintain the status quo in the scientific, economic, and political fields. Due to Schauberger's vision of technology and the world, his ideas continue to be appreciated in fields of unconventional energy and nature-based design. Such an emphasis on honoring and imitating natural processes is particularly important as society seeks efficient solutions in terms of renewable energy sources. This experience demonstrates that all pioneers working in the field of alternative energy have an uncertain path between invention and oppression. 3. The Handleshot Generator. At the end of the 1920s, an American inventor named Lester Handleshot made a surprising claim. He claimed that he had developed a device capable of generating free energy called the Handleshot Generator. This invention was described as using the Earth's magnetic field to produce electricity without requiring conventional fuel sources. The revolutionary device was described as a generator that operated autonomously, using a complex network of coils and capacitors to independently produce energy. Handleshot's initial demonstrations were spectacular, powering bulbs and motors, sparking the imagination of the public, the media, and potential investors. Many were attracted to the idea of a revolution that would bring about a radical change in energy production and consumption. However, not everyone was thrilled at the prospect of such a disruptive technology becoming a reality. Surprisingly, once people began to show interest in Handleshot's work, efforts to discredit him emerged. Critics began to debunk his generator, publicly presenting a device they claimed was identical to Handleshot's, but which did not work. This act of defamation served as a clear indication to Handleshot's supporters that powerful interests were determined to undermine his invention. Despite significant skepticism and opposition, Handleshot continued to perfect his generator, convinced of its potential. By the end of 1960, he believed he had made significant enough progress to attract the interest of the US Navy. With renewed hopes, he prepared 2 models and a detailed 56-page proposal. Unfortunately, his advances were rejected, and his proposal was ultimately turned down. A tragedy occurred in April 1961 when Handleshot's son found his father dead, an incident later described as him taking his own life. However, due to a limited investigation, many, including the family, believed it was murder. They concluded that Handleshot's work could have been particularly harmful to the financial gains of major energy companies. It seems that Handleshot had even been warned by a major corporation to cease any work related to his generator under the threat of serious consequences. Reports suggest that Handleshot was paid $225,000 to halt his research for 2 decades, highlighting how far these corporations were willing to go to protect their interests. Handleshot shared his concerns about his personal safety with his family, highlighting how serious the threats against him were. His mysterious death and the blocking of his revolutionary work continue to stir intense curiosity and debate. Lester Handel's story serves as a compelling narrative about the conflict between innovation and established interests, raising questions about the possible suppression of revolutionary technologies in the face of powerful economic forces. To Project XA, the story of Dr. James D. Mold and the cancer-free cigarette should outrage any smoker and anyone who has lost a loved one due to tobacco smoking. Although rumors have long circulated about the dishonesty of tobacco companies regarding the risks of smoking, revelations related to Mold's revolutionary work and its subsequent neglect underline the industry's greed. Dr. Mold initiated a pioneering effort to develop a cigarette that would not cause cancer, a project known as the XA Project. With the initial support of the Leo and Meyer's company, Mold tirelessly collaborated with the Ad Little company on this ambitious task. After 25 years of uninterrupted work, Mold invented Xade, or the palladium cigarette, which used palladium and magnesium nitrate to eliminate carcinogenic chemicals from cigarette smoke. Laboratory tests showed that these cigarettes effectively reduced the incidence of cancer in laboratory animals. The company directors suddenly lost interest and withdrew support for the project, causing the palladium cigarette to never go into production. The basic reason was simple and frustrating. The company's lawyers argued that by introducing a new, safer product, the public who had used the previous, relatively more dangerous products would repeatedly sue the company. This decision highlights the tobacco industry as being allergic to any action that could protect profits, regardless of its harmful impact on public health. Could such a cancer-free cigarette have changed the tobacco industry? 1. The first electric car. At the end of 1990, General Motors launched its first mass-produced electric car on the market, which it named the F1. This vehicle appeared at a time when society was beginning to be sensitive to air pollution, oil dependency, and other impacts of cars on the environment. The F1, when initially launched, was produced in a limited series of 8 CD units available only for lease, thus gaining a solid fan base. Those who drove it stated that the car was efficient and believed that this vehicle paved the way for a brighter and more environmentally friendly future for the auto industry. However, in 1999, shortly after its manufacture, General Motors ceased production. The company cited economic reasons, arguing that the car's batteries had limited autonomy, which made it difficult to meet consumer expectations in terms of convenience and long-distance travel, subsequently labeling the vehicle as unprofitable. However, many observers did not respond well to this official justification. Skeptics and passionate supporters of the electric vehicle movement speculated that the story was more complex. Many believed that the oil industry, feeling threatened by the rise of electric vehicles that could disrupt their business, exerted pressure to suppress this emerging technology. General Motors' response was severe and unprecedented. A company halted Avon production and initiated a campaign to recover and destroy every unit. This was not just a recall, but a deliberate effort to prevent these vehicles from becoming symbols of a technological revolution. Instead of allowing them to remain with users or be kept as historical artifacts, GM Motors destroyed them, effectively erasing a significant chapter in automotive history. This extreme measure was widely interpreted as an attempt to hinder the progress of electric vehicle technology and protect the traditional auto market dominated by internal combustion engines. The saga of the rise and fall of the F1 has been documented in various films and discussions, the most memorable being the 2006 documentary Who Killed the Electric Car. This film delves into the intricate web of corporate and commercial interests behind the disappearance of this groundbreaking electric vehicle. From water-based fuel cells and Wasp X-Jet to the first electric car, these innovations have shaped the landscape of energy technology. Which of these innovations caught your interest the most? Write in the comments. Thanks for watching.